Hi everyone. Today we'll be starting a new series called as Learn With Me series. In the series, among the upcoming videos, the first video is about erythropoiesis, right? So what is erythropoiesis? Erythropoiesis is nothing but the production or formation of red blood cells. So there are different types of cells are present in the blood, among which erythropoiesis denotes the formation of red blood cells. In the different types of cells comes from one stem cell. This stem cell is called as PHSC. PHSC அப்படினா pluripotent hematopoietic stem cell. இந்த PHSC இருந்து தான் red blood cells, WBCs and platelets form பண்ணும். Right? This PHSC has two types of properties. Those are self-renewal and differentiation. Self-renewal is nothing but the property of duplication. PHSC differentiates into different kinds of cell. அப்படி பண்ணும்போது the number of PHSC in itself decreases. For it to maintain the reserve of the stem cells, it has a property known as self-renewal, which means it duplicates itself. Another property is differentiation. This pluripotent hematopoietic stem cells gives rise to different types of cells, as I told before, which are the red blood cells, white blood cells and the platelets. Right? Pluripotent hematopoietic stem cell gives rise to two types of committed stem cells. This committed stem cells is nothing but the myeloid stem cells and the lymphoid stem cells. Myeloid stem cells again is a trilineage stem cell, which gives rise to erythroid progenitors, granulocytic and monocytic progenitors and the megakaryocytic progenitors, among which we are going to focus upon the erythroid progenitors, which is nothing but the red cell progenitors. Red cell progenitors are again of two types, burst forming units and cell forming units. Right? A recap: pluripotent hematopoietic stem cell has two different properties, which is self-renewal to maintain its reserve, differentiation to give different types of cells. This pluripotent hematopoietic stem cell gives rise to two committed stem cells, myeloid and the lymphoid stem cells. Myeloid stem cells gives rise to progenitor cells. In the progenitor cells, one is red cell progenitor. Red cell progenitors are nothing but the burst forming units and the cell forming units. These progenitors in turn gives rise to what are known as the red cell precursors. As we have seen, the progenitor cells gives rise to the precursor cells. There are four types of precursor cells, which are nothing but the pronormoblast, basophilic erythroblast, polychromatic arblast and orthochromatic erythroblast. The first morphologically identifiable cells of the erythroid series are the pronormoblast. Right? The size of the pronormoblast is 20 to 25 micrometer. And the nucleus in cytoplasm composition is 80 by 20%. Nucleus occupies 80% of the cell and cytoplasm occupies 20% of the cells. The cytoplasm is predominated by polyribosomes, due to which there is high concentration of RNA. It also gives a basophilic characteristic to the cytoplasm. The next cell after pronormoblast is the basophilic erythroblast. Pronormoblast gives rise to basophilic erythroblast. The size of this basophilic erythroblast is 15 to 20 micrometer. And the composition: nucleus occupies about 75% of the cell. This nucleus is peculiar, which contains both dark heterochromatin as well as pink euchromatin. This heterochromatin and euchromatin are interspersed with each other, which gives a peculiar appearance to this nucleus of basophilic erythroblast, which is nothing but the wheel spoke appearance. Basophilic erythroblast is also the cell where for the first time hemoglobin appears. After basophilic erythroblast, we have polychromatic erythroblast. Polychromatic erythroblast is also called as the intermediate erythroblast. The cell size of this polychromatic erythroblast is 12 to 15 micrometer. The composition of the cell: nucleus occupies for about 50% of the cell. It is also called as the intermediate erythroblast. The heterochromatin clump organization in this polychromatic erythroblast is such that it gives a checkerboard pattern. So what is the peculiar pattern for basophilic erythroblast? Yes, wheel spoke pattern is peculiar for basophilic erythroblast and checkerboard pattern is peculiar for polychromatic erythroblast. Why is it called as polychromatic erythroblast? Because it contains acidophilic hemoglobin and eosinophilic RNA, it is called as polychromatic erythroblast. This polychromatic erythroblast in turn gives to what is called as orthochromatic erythroblast. So the orthochromatic erythroblast is next in the erythroid series, which is formed from the polychromatic erythroblast. The cell size of this orthochromatic erythroblast is 7 to 12 micrometers. The nucleus is small and pycnotic. Chromatin organization inside the nucleus gives a peculiar appearance to this cell, which is the cartwheel appearance. So we have seen three peculiar appearances in the erythroid series, which is the wheel spoke appearance, checkerboard pattern and the cartwheel appearance. The checkerboard pattern is in the polychromatic erythroblast. The wheel spoke appearance is in the basophilic erythroblast, and the cartwheel appearance is in the orthochromatic erythroblast. Orthochromatic erythroblast is also called as the late normoblast, and the mitosis is absent. The last mitosis takes place from polychromatic erythroblast forming orthochromatic erythroblast, after which there is no mitosis taking place. After looking at the four types of precursor cells, the last precursor cell, which is the orthochromatic erythroblast, gives rise to mature red blood cells. There are two types of mature red blood cells, which are nothing but the reticulocyte and the erythrocyte. Reticulocyte is also called as the juvenile red cell. Do remember, mature red cells of the erythroid series are reticulocyte and erythrocyte. Reticulocyte is also called as the juvenile red cell. It contains reticular network, which can be stained by the supravital stains. This cell is slightly larger than the RBC. Reticulocytes are present in the bone marrow. Upon diaperesis, comes into the bloodstream and changes into erythrocyte. Erythrocyte is nothing but the red blood cell. The whole process of erythropoiesis takes place from 7 to 9 days. It takes about 5 days for the formation of reticulocyte from the precursor cells, and the remaining 2 days, reticulocyte changes into the erythrocyte. So that's all about erythropoiesis. To summarize, erythropoiesis is the production of red blood cells. It starts from the pluripotent hematopoietic stem cells, which has two properties: self-renewal and differentiation. This pluripotent hematopoietic stem cell gives rise to a committed stem cell called as the myeloid stem cell, which in turn gives rise to progenitors. Progenitors of the red blood cell series are burst-forming units of erythroid progenitors and cell-forming units erythroid progenitors. Progenitors in turn gives rise to precursors. There are four types of precursors: pronormoblast, basophilic erythroblast, polychromatic erythroblast, and orthochromatic erythroblast. The first identifiable cell of the erythroid series is the pronormoblast. There are three peculiar appearances. Basophilic erythroblast has wheel spoke appearance, polychromatic erythroblast has checkerboard pattern, and orthochromatic erythroblast has cartwheel appearance. Orthochromatic erythroblast gives rise to mature cells. There are two types of mature cells, reticulocyte and erythrocyte. Reticulocyte is also known as the juvenile red cell, which is slightly larger than the erythrocyte. It contains reticular network and thus the name reticulocyte. This reticular network can be stained by supravital stains. Hope you understood. Thank you.